Very warm welcome to Storage Area Network. Myself, Dr. Lokesh MR, Professor, Computer Science and Engineering. Along with me, Professor Amrut, Assistant Professor, Information Science Department, is handling Storage Area Network with us. Now, last few session, we have completed module first. Okay, we have started module first. Okay, in this module first is nothing but a the storage systems module. Okay, in the first module, we have discussed about what are the different types of architectures. We have two types of architectures. One is client server fashion, another one is a information centric client server fashions, and then we have discussed about what are the components are available in the data centers by conveying the information, what do you mean by data centers and all, and then we discussed about what do you mean by virtualizations and how virtualization can be done for the hardware and how virtualization can be done for the memory and how virtualization can be done for the computing. So that we have discussed, and we discussed about the cloud computing, and we have completed the first section of module 1. In the second session of the module, we discussed about what do you mean by in the second section we have discussed about the data center environment. Okay, data center environment. Okay, so next we have to deal with the third module by the name called data protections. Okay, so data protections. So whenever we are discussing about the third topic by the name called data module, so in this data module, so in the data centers, data are stored in the form of disks. Okay, data are stored in the form of disks. It's not only stored in a single disk, there will be a many number of disks. Okay, many number of disks, and each disk is managed by a logical volume managers. Okay, we call it as LVM. Okay, volume managers. That means the address of the data which is stored in the data centers will be stored keep a track by the form of address. Okay, by the keep the track of address. Okay, that address is called as logical volume managers. Okay, that logical volume managers can be used as a reference, and we do the virtualization operations in it. Okay, so whenever we are using a different arrays for storing our data, so that data will be stored in a different arrays of disk. Okay, so if you want to convert the arrays of disk into a single disk and make a large volume of disk, okay, and that large volume of disk are used for making the data availability for the end users. So and increasing the performance of the data providing, okay, and also to protect from the disaster management. Okay, so in that to perform such type of operations, that means to increase the performance of the storage information and to make the availability by making a duplications or mirroring the disks into a copy of it, and the third one is if any disasters occurs in the storage area network data centers, so that can be protected or recovered by using a parity generators like that. So we can protect our data by using a concept called RAID. Okay, so the word RAID is used as redundancy array, independent disks. Okay, so that means redundance. Okay, that means copy of different arrays. Array in the sense that it is a disks. Okay, array of disk of independent disk combined to make a single large volume. Okay, single large volume disks. Okay, is called as RAID. Okay, so this RAID has many advantages. Earlier, whenever we are want to perform some operations like to increase the performance of the disks and all, we are using a normal disks like individual disk. If you use, the life expectancies of the individual disks may be varied. Okay, depends upon the mean time failures. Okay, sometimes the disks may fail if you are using that disk 24/7. So that means assume that one disk which will be used for 7,50,000 hours of running. Okay, and it uses 100 disks of an array. So if you divide, so obviously if you are using 100 devices by 7,50,000 hours, so it will comes under 7 hours 50 minutes. That means the single disk if you use, and if you ask for the performance, it may not give a good performance. So for that purpose we make a redundant, that means a copy of an array of disks. Okay, copy of an array of disk like this. Okay, disk, and we call it as disk 1 and disk 2 and disk 3. Say like that, disk n, like that we combined all the disk and we call it as one array. Okay, one RAID. Okay, and this RAID 0, like this type of arranging of disk, array of disk into a single large volume of disk is called as an array. By performing this, we can increase the performance of the storage. So that is one objective. And to make the availability of the storage devices to the n number of users, and the capacity also we can increase. I told you we can increase n number of disks. Okay, like that we can increases the number of things. Okay, that means RAID will provides the capacity is increased, and then the high availability of the data, availability of the data is also high, and the performance when compared to a single disks, okay, single disk, the performance also will be good, okay, compared to the use of single disk. So we go for a RAID operations to increase the performance of the storage area informations. Now let us understand in detail how these RAID concepts is utilized in the storage area networks. In almost all the data storage data centers, we use a concept called RAID, and we increase the performance of the data storage capacity and availability and performance. Okay, that is one thing. So we addresses in these issues. After understanding this third concept, we have to understand what do you mean by RAID. RAID is nothing but redundant array independent disk. Okay, that means independent disks are arranged in the form of an array, the copy of an array, and it will be used it. Okay, not only that, so this RAID, how it is built up. Okay, how it is built up after completing this operations like data protection topic today which we are discussing, you people has to come out with the understanding of what do you mean by RAID, and what is the need of it, and we are understanding how actually we build a RAID. Okay, so I told that RAID RAID can be used for making the availability of a data storages. How do we make it? Okay, how do we build the array into availability of many users? How do we do that? That is one thing. And the second thing is, if any disasters occur, okay, how do we manage, okay, to recover the data which is lost by us? Okay, that we will do by designing the concept of RAID. And how do we increase the performance by making a mirroring operations, okay, or scripting. That means the slice of data, single data is divided into different strips, and we make the performance of the disks should be utilized efficiently. How do we do that? These are the things we are discussing, and we compare. As I was telling, that we can divide the we can design the RAID operations into different factors, and we can increase the performance of the data centers, right? How do we do that? By one is the concept of script, another one is by using something called mirroring. Okay, mirroring. So the third concept, something called parity. Okay, parity RAID. Okay, we call it different type with different types of RAID. So not only those things, there are different concepts. We can do it RAID 0, RAID 1, and RAID 0 plus 1, and RAID 1 plus 0, RAID 3, RAID 6, RAID 5. Like that we can design the RAID operations into a different levels. Okay, what are the different levels, and what level will give a high performance, what level will give a high availability, and what level of RAID will give a large number of capacity, that we need to compare after completing this session. Okay, along with that, we are understanding what are the risk impact in designing the disks. Okay, risk impact in designing the disks, so that we will understand. First, let us understand what are the components of RAIDs. Okay, let us understand what is the components of RAID array. As I was telling, that RAID is a group of disk. Okay, so usually whenever we are accessing any data in the data centers, we access the data in the data centers by using the host machines. Okay, host machines like this. Okay, so host machine, we have told what do you mean by host machines. Host machine is something like our computers, which can be given input to the data centers through the applications and as well as the operating systems. So now we have to discuss about what do you mean by RAID array components. Okay, so RAID contains a host. The components of the RAID array contains a host. Along with, we are using some networks. Okay, fiber channel networks. Okay, fiber channel networks, we are using it, and these RAID will be having a components, okay, by the name called RAID controllers. Okay, that means whatever the operations which we are using, we need to use a controller in between. That means before connecting to the storage arrays, like we have a physical disks, so I will call it as a physical disk. Okay, so this physical disk is used. Okay, like it may be something like this is the physical disk, and one more disk by the name called hard disks. Okay, hard disk. Okay, these hard disk can be represented in the form of like this. So it may be many number of devices. Okay, each hard disk, each disk, physical disk and the hard disk will be having a logical arrays. Okay, will be having a logical arrays. So these logical arrays in turns, this matter. Okay, the physical disk as well as the hard hard disk. Hard disk is the disk which can be utilized. It's utilized by the devices, like how a physical disk will be looking like that hardware devices disk will be used. Okay, along with that we are having some logical arrays. So that means the address of the disk's information is also present in it. This is the actual hard disk. So this information is connected, okay, this physical information is connected to the RAID controllers. Okay, so this is the component of an array. That means RAID array contains an host. RAID array contains an infrastructures to be connected to the RAID controllers. RAID controllers contains the physical disk as well as the hard disk along with the array disks. Okay, this is the information regarding the array components. Now let us understand how do we implement this RAID array. Okay, how do we implement the RAID array? Okay, RAID, how do we implement it? So whenever we are talking about the implementation part, of the RAID array, the implementation of the RAID array can be done by using a hardware components. Okay, like how I have shown these hardware components, like that we can performs the RAID operations by using the hardware components. These hardware components contains a specialized disk controller, disk card contains a specialized disk controllers like this. This is the disk controllers. So all the drives, okay, all the drives which is connected to the host machines through the networks will be having a controllers. So these controllers is acts like a array of disks whenever we talk about the host. When we see the RAID operations in terms of disks, okay, in terms of host, so it looks like a regular disk only. It hides all the informations, even though we have a lot of hard disks are arranged in it. So those lot of hardware disks are controlled by the operating systems. Okay, only system administrators is knowing what type of, how many number of arrays of disks are present in it by understanding the controllers. This controller will controls all the arrays operations. Okay, like that the implementation of array can be done by the hardware, by terms of hardware, by using a controllers, or else we can have the implementation of hardware components by using the software. Okay, by using software, host machine itself having an operating systems to manage a RAID operations. Okay, that means instead of accessing the single disk, we can access the multiple disk by combining the multiple disk. That is called as a RAID. So those type of operations can be done by using a software. How do we do it? By incorporating a software to the operating system itself to perform the RAID operations. We can develop a RAID, we can implement the RAID operations. So whenever we are adding applications to the operating system itself for accessing the different arrays, array of disks, so it uses CPU workloads. Okay, the drawback of software implementation of RAID is it uses CPU utilization, then the performance will be decreased and it will not support all levels of RAID operations. We will discuss what do you mean by levels of RAID and all in the next things. Okay, now the drawback of software implementing of RAID is it utilizes the CPU operation, CPU computations. Okay, for that purpose the RAID will be very difficult in implementing with the software. So many things which will be done in the implementation of a RAID is done through the hardware itself. Okay, next let us discuss what is the levels of RAID. Okay, levels of RAIDs. There are different levels of RAID, as I was talking. RAID 0, RAID 1, RAID 3, nested RAID, like that. Now let us understand what are the different types of RAID levels. RAID levels. Okay, now let us understand the concept of what do you mean by RAID array. So we have something called RAID 0. So for example, RAID 0. This RAID 0 is nothing but a stripped. Okay, stripped. It's an array of stripped. What do you mean by that? That means, for example, we have one disk. Okay, and this one disk can be scripted, okay, by using a script line like this. That means we are dividing the single array into a multiple disks. Okay, how do we if you perform such type of things, we can increase the performance of the performance operations, storage performance. Instead of storing the data into a large volume dumping, so we arrange the data by dividing the different scripts. Okay, divide script 1 and script 2, like that. So it is easy for searching operations also. It is easy for storing to a particular scripts also. Instead of storing from the beginning till the last, it can be stored within the scripts. In details we will discuss. Similarly, we have something called RAID 1. Okay, I am talking about, there are different types of levels of RAIDs. RAID 1. This RAID 1 is used for mirroring operations. What do you mean by that? That means we have one disk. Okay, the same copy of the disk is arranged like this. Okay, same copy of the disk is arranged like this. Such type of disk is called as a RAID 1. Okay, so or else sometimes we use as nested RAID. So either we are using RAID 1 plus RAID 1, okay, which performs a mirroring, that means copy of things, along with script. Okay, along with the script, or in sometimes we can use some scripting stripped of data along stripped of disk along with the mirroring operations. Like that, we can perform both operations, either by using a stripped operations, either by copying the same operations, like that. Okay, so the fourth types of array is something like parallel access array with dedicated parity disks. Okay, parallel access disks. Okay, a parallel access array with dedicated parity disk. This is the fourth type of RAID we are using it. Here what we will do it, we are using a group of array like this. Okay, group of array like this, which is arranged parallelly. So all are connected into a parallel. Okay, from the host. Okay, assume that this is a dedicated disk and we have a host here, host machine, that is computer, which we have talked about. So these host machines are connected to the parallel, and special dedicated parity array disk are used. Okay, this parity disk is used for correcting the error occurred while any disk is operation. For example, this is disk 40, this disk 4, this disk 1, this disk 1, and this disk 1. Okay, so the whole dedicated disks contains 5, 6, 7 data is 7 is stored here. Okay, if any one is gone through the parity disk, we can recover the operation. That means this fourth array, fourth RAID operation is used for recovering the data which is not discussed, which will be destroyed due to the disaster management. Okay, that means we can perform a recovery operations in the fourth array levels. Okay, in the next one we discuss about 4 script with independent disk array. So we call it as RAID 4. Okay, RAID 4. In this RAID 4, what we will do, we are having a 4 script. Okay, 4 arrays like this, 4 arrays like this, 4 array. Okay, in these 4 arrays are stripped like this. Okay, depends upon the number of stripped required, along with one parity array which is of special types, which uses for redundancy operations if any error is occur. Okay, so this if any disaster occur due to the disaster purpose, then from these component, okay, parity components, we can generate the new disk which is not disaster occurs. So such type is called as RAID 4. That means it contains a 4 stripped array, 4 stripped independent array with the dedicated parity disks. Okay, so we have one more type of RAID by the name called RAID 5. Okay, this RAID 5 is used as a stripped of independent disk which distributed parity in it. Okay, what parity disk, what do you mean by that? That means we have a disk like this. Okay, we have a different type independent disk like this. So this each independent disk will be having a parity bits. Okay, this independent disk will be having a parity bit in it. So that means if any disasters occurs, okay, so this disaster occurs can be recovered by the parity bit itself. That is called as RAID 5. Okay, so similarly we have one more type of RAID by the name called RAID 6. Okay, RAID 6. So in this we have 6 script array, like how I have shown the different types of array, along with dual distributed parity. Dual distributed parity in the sense that we have an independent array like this. So each independent array will be script like this. In this we have parity 1 and another thing is parity 2. In each bit, okay, in each disk will be having this parity. The purpose of this parity bit is used for recovery operations. This anyhow we have scripted, if any things happens in these portions, this parity will be checked, and if any things happens in this type of script, this parity will be checked. Like that, some parity bits are used. These are the different types of levels of array is used. Okay, array 0 is used for stripping, array 1 is used for copying, mirroring, and nested RAID, where we can use either script and mirror and script like that. And we have a parallel access with the dedicated parity bits. As I was telling, that parity bit is used for recovering purpose of any disk which been destroyed while using it. And we have a RAID 4. So where RAID 4 is uses 4 scripted arrays along with one dedicated parity bits, and RAID 5 is used as same dedicated array of disk along with distributed parity array. The parity is distributed in the RAID 5, and RAID 6 is contains a dual distributed parities are available. Like that, different types of arranging of the disk. See, many single disks is arranged into a group of disk, and each disk is used for different purpose, and increasing the operations of the disks will be learned by using the concept. Okay, so these are the different types of levels we are using it. So in the disk RAID 0, so the data are distributed across the hardware hard disk. As I was telling that we have something called physical disks. So physical disk, okay, physical disk and hard disks, right? Hard disks, okay. These hard disks are the actual disk, many number of disks which will be used. Okay, these hard disk in a RAID 0, the data are distributed across the RAID sets. Okay, distributed across the RAID sets in the sense that, so the data which we are storing in these data centers are distributed. It is not a concentrated. That is what it uses. So by this, it allows multiple data to read and multiple data to write to improve the performance of the operations of the data storage. What do you mean by that? That means whenever we are using a RAID 0, so this RAID 0 will be divided into different stripped like this. Yes, strips. Okay, we call it as stripped 1, stripped 0 and stripped 1. Okay, this is the way how actually the disk is been divided. Hard disk is been divided. Hard disk is been divided. So if stripped 1 is in the read mode, if the stripped 1 is in the read mode, and the stripped 1 will be in the write mode. All the, like, read and write cannot be done simultaneously, but if you are dividing the disk into a different scripts like this, we can perform a reading and writing operations parallelly. So but it will increases the performance of the disk, but it won't have a protecting mechanism. If one disk is disastered and it cannot be conquered, okay, it cannot be recovered. So and similarly availability of a disks also will be failed. Both the disk will be utilizing. Assume that if the reading disk, in reading disk we need to write, at that cases it may not allow to perform. This is the drawbacks in the RAID 0. So the scripting, to overcome that, we go for a mirroring. That means we use a copy of the disks, one more copy of the disk, and then we try to increase it. So similarly, as I was telling that the component of the RAID 0 contains an host machine as well as the RAID controllers and the array of disk, which will be divided into a different sectors like this. That is the way how the components of the disks are present. Okay, so in disk 1 I was telling that the drawback, so drawback is availability problem, because both the disk will be in something like it will be in the read mode and the write mode. So if you want to perform a write operations in the stripped 0, it won't allow. To overcome that, we use a two different disks like this, with an array. Okay, one operations can be used for read, another operations can be used for writing operations. Okay, one operations can be used as read and one operations can be used as write operations, and these two scripts will be combined and it will be given to the host machines. Here, assume that this is a write script, this is the script 1 is script 0 is write, and here the script 1 will be of reading mode. Okay, that means we copy of it and we make it a both reverse. with same availability. So that means this will become script 0 has become read in one disk, and disk 2 it become a write, and disk 1 it will become a write, and disk 2 script 1 become a read, so that even the host requires to read and write operations either in the script 0 and script 1, it is available, because we make a mirroring of the disk which is present like this. We are making a copy of this and we make the availability high. Okay, by this event, even though we are available, if any one disk is failure, okay, so it cannot be replaced by the another things. To overcome that, so we use the other concepts. Okay, we use both the concepts, like either 1 or 0, like that. Okay, third concepts. So here whatever we are doing, we are just copying the data in disk into another group. That means the capacity availability will be high, but the capacity what we are storing is simply it is making a backup. Okay, so the same thing, it is not utilizing proper utilization of the resources. So the hardware components which we are using for the RAID 1 is, it contains an host machine, and it contains a controller, and the 2 copy of the disk, and the 2 copy of the disk. Okay, now let us discuss how do we utilize the combination of script along with the mirror. Okay, so what is the use of using RAID 0? RAID 0 is nothing but the stripping, that means making a slice. Along with that, we have to make a mirror of the script. If you are performing such type of operations, so if one device is failed, okay, if one device is failed, it won't fail for all the things. Okay, all the other devices will be done. That means we can just copy the same thing by the same disk by the another disk by performing a reversing operations. That means if you are using the 0, that means stripped along with the mirroring operations, we can avoid the occurrence of the failures, and we can perform the recovery operations. Okay, instead of just adding a extra disk for parity checking and all. So next we will discuss what it is. Just we will make a combination of stripped as well as one more bit. If anything is failed, it can be recovered. So in some cases what we will do it, just we will mirror the things. RAID 1 is nothing but a copying of it, and then we will strip the things. So by using those things, we can multiply the operations. Okay, like if any starvations occurs due to the data, so that can be recovered by using a 0 operations like that. So we can design the RAID operations into a stripped 0 and stripped 1, and we can use the applications advantages of each operations. So whenever we perform a stripped as well as a mirror, so it will be used the components of the stripped as well as a mirroring operation. That means nested operations will be done as host machine and contains a host machine as well as a RAID controllers, and these RAID controllers will be divided into different strips, and different stripped can be mirrored, and we call it as a RAID 0 and RAID 1. Okay, that means copy also is done along with the stripping. Okay, both the things will be done. If any one is failure, so the other RAID 1, the copied mirror will be utilized for the recovering of operations, recovering the previous one which is disasters. Okay, so that is how actually the things is done. So now let us understand how the parity is generated. Parity is, as I was telling, that we have a host machines like this. This host machine is used for requesting the data to access it. This host machine is used with the RAID controllers. It is an hardware components. All the host machines will be use the RAID controllers, and then the disk will be arranged. Okay, so while we are arranging the disk, okay, like it is a parallel access array. Let us discuss how parity disk is generated, how the parity disk is generated, like that. So this parity disk is generated by using a different methods like this. Okay, I'll talk about how actually the parity generating is done. Okay, let us have a array of disks, okay, like this. Let us array 1, which is having the content of the disk as 4. Okay, then let us have the array of disk which contains a 6. Okay, then let us have an array of a disk which is of missing in nature, and let us have an array which is having of disk 7. Let the other disk is having 18. Okay, like that. Like let I'm taking the example of it. If you calculate 4 plus 6 plus 1 plus 7, okay, so it has to become a 18. Okay, the last bit, okay, the last bit should become a 18. So assume that 4 plus 6 plus question mark plus 7 is equal to 18. So the last array bit is nothing but a last array bit is nothing but a parity bit, so where which covers all the operations. If you check it, so the addition of all these along with the minus, that means 18 minus 17, the 1 we will get, so 1 will be added to it, like this. That is how the parity bit is utilized compared to the other things, that means for recovering the operations. Now let us discuss the scripts, what RAID 3 and RAID 4 will do. Okay, I'll call it as a RAID 3. Okay, I'll call this as a RAID 3. Okay, I'll call this as a RAID 3. So earlier we discussed about RAID 1, so which is nothing but a script. RAID 2, RAID 0, which is a scripting. RAID 2 is the mirroring operations, and RAID 3 is the parity bit. Okay, so RAID 3 and RAID 4 let us discuss in details. In RAID 4, the script, it has a high performance by using the parity for improve the fault tolerance. If any fault tolerance is occurred in designing the disks, hard disk, so that can be recovered. See, if one in the RAID 3 we use one dedicated parity informations, parity disk for recovering the operations, and this parity bit is also used for reconstructing the data. So here in RAID 3 we can read and write can be done at the entire scripts. Okay, it's not that in a dedicated script we are using the read operations and write operations. In RAID 4 we use an independent single disks for performing the read and write operations. So in a RAID 5 and 6 it's similar to the RAID 4, that means it contains a parity bits along with the distributions across all the bits with the dedicated disk. That means the disk is distributed, the parity bit is distributed to all the disks for recovering any disasters occur. Okay, in RISC 6 it contains both parity bits. Okay, 2 parity bits will be increased. That means the probability of failure of a disk in the disk 6 is very less compared to other disk, because it contains a 2 parallel disk. So two parallel bits we have to recover it, and we can perform the operations. Next, let us discuss the comparison of the disk. Okay, RAID, what are the comparisons? RAID 1, what is the performance, and RAID 2, RAID 0, what is the performance, like that. Okay, let us compare the disk in different types of disk. Okay, so in RAID 0, we are using minimum 2 disks for performing the operations, and the storage efficiency is 100%, and the cost is also low because we are just using one script, okay, one disk, and then we are recovering it. Okay, so we use a one disk, and we perform the management. Okay, it's where it uses very low cost, and it uses very good accessing of data, because we divide the data into two things and we use it. Okay, that means very good for both random and sequential read operations, and it is also very good for write operations. In RAID 1, so it uses minimum 2 disks for performing the RAID operations, but the storage efficiency will be 50%, because we divide the disks into two groups in the RAID 0. RAID 1, we just take the copy of it and we generate it. For that purpose, the storage efficiency will be 50%, and the cost of the RAID 1 is very high, because we need to invest for the redundant disks for that purpose, and read performance is very good. For those drawbacks only, in read performance is moderate. Okay, in RAID 1, for that purpose only we go for the RAID 1, and we use write operations is slow compared to the single disk, because we need to write for the both the disk. Okay, in the RAID level 3, we have to use 3 disks. One is for redundancy disk or scripting of a disk, along with one parity disk we have to use it, and the performance storage efficiency depends upon the number of bits we are arranging in it. Okay, so along with one parity bit we have to leave it, and depends upon the how many number of bits array of disk which we are using it, that we are using it, and cost depends upon the usages and applications. So assume that we need a 100 number of disk. In that 100 number of disk, we need to identify all the 100 number of disks recovery operations. Okay, at that cases it is possible. It's not possible to have a good cost. We have to invest 100 number of parity bits disks to recovery operations in the disk 3. Along with that, we have to understand, but we can access the read operations parallelly. Read operations is very good, and write operations will be fairly fair, or else it will be a poor, because we are using a sequence of array of data along with the parity. Okay, for that purpose. In the RAID 5, so we are using once again 3 bits. Okay, in that the parity bits are distributed among the disks instead of keeping in a one disk. Okay, and it is very good for reading performance, and it is fair for a write performance, as how actually RAID 3 is used. Similarly, the same things are there regarding the performance. And regarding the RAID 6, so we are using 4 bits. That means both each bits contains 2 parity bits, and depends storage efficiency depends upon the number of bits which we are using it, along with 2 extra parity bits we are using it in the each disk, that we have to consider. And the cost is moderate, because RAID 1 contains one parity bits, but in the RAID 6, RAID 5 contains one parity bit. In RAID 5 contains one parity bit, RAID 6 contains two parity bits, and reading operations is very good comparatively, and compared to all other things, write operations in the RAID 6 is good, but it uses a small random operations. But whenever we are using a RAID 0 and RAID 1 for performing the operations, okay, so it is very good in storage efficiency is 50% since we are using replica of the same data, and cost is also very high, but it is very good in reading performance and very good in writing performance. The performance of reading and writing will be very good if you are using a 0 plus 1 or 0 plus 1 1 plus 0 RAID operations, or 0 plus 1 RAID operations. Writing and reading operations will be good compared to the all the other RAID operations. Okay, next we will discuss about what is the impact. Okay, impact on performance. Okay, RAID impact on performance. What is the RAID impact on performance? RAID impacts on performance. Okay, RAID impacts on performance. The impacts of RAID depends upon the how many number of copy we are using it in the RAID. Okay, for example, if you do a mirroring operations, okay, the reading and writing segments is introduced. For the writing we are requires more time because we need to copy to a many disk, okay, and then we have to recover it like that. So, okay, writing performance reduced. Okay, so will be writing performance. By writing the performance, the impact on performance is writing operations. Okay, writing operations is tedious. Okay, the second one is introducing the parity bit. Okay, parity bit for recovery operations, recovering the disks. Okay, in this we need to have a extra disks. Okay, extra disk to it. These are the two impacts on the performance of performance of the RAID. Okay, so to overcome that we use a different techniques like XOR operations and all. So those can be done by the different things. Okay, this is what we will learn in this module. That means we understood what do you mean by RAID. RAID is nothing but a redundant array independent disk. Independent disk can be arranged into a single group, and what is the purpose of performing the integrating of independent single disk into a single disk? To increase the performance of the storage operations, and also to increase the availability of the storage operations, to make availability, and to check a error in the disks. Okay, so like that three things we have understood. The need of RAID is to increase the performance, to increase the availability, and third one is parity, error checking. Okay, that is the things we have understood, and we have understood how we have built the RAID. Okay, RAID is built with the different components like host contains network, and network contains a RAID controllers, and RAID controllers contains a physical disk as well as the hard disk. So each physical disk contains the logical address, and hard disk contains also a logical address. This is the components of the disk we have learned. And then how do we arrange the disk into a different way to increases the availability and to increase the error checking, and make our ride as a more performance well. Okay, so that is how we have understood. Thank you so much for this.